We're in section 3.2. Chapter 3 is about numerical summaries of data sets. Section 2 is about measures of dispersion, which we say dispersion is the same thing as spread. How spread out is the data? What kinds of numbers can we use to represent the spread? One number you can use is called the sample range. It's just the max minus the min, the biggest value minus the smallest value. So that's the distance between the largest and smallest value in the data set. So the data occupies an interval that big. It's max minus min, so here we have some data here, 1, 2, 3, 4, 5 values. Here's the maximum, 21, and there's the minimum, 36. So the range is 36. It's 36 units between the 21 and minus 15. That's the idea. That gives you an idea how much spread there is in the data from max to min, that distance between max and min. Another calculation, which is a little more complicated to do, is called the sample standard deviation. So the standard deviation involves a number of steps. First we compute these things, deviation from the mean. So that's the distance from the mean. So take the value minus the mean. That gives you the deviation from the mean. And then, that's the first step. You get those deviations for every value. You square them. So now you've got squared deviations. And then over here it says we're going to sum those values. Sum them. Third thing. And then we're going to divide by n minus 1. N is the number of values in the data set. And finally, that's fourth thing. And then finally, number 5, find the square root. Okay. Those are the steps, quite a few steps. So one way to keep that organized is to use a table. So here we have the names of the variables, x1, x2, x3, x4, x5. Those are the names we use for the first, second, third, fourth, and fifth data set. First, second, fourth, and fifth data value. Then we'll put the values that we have associated with those from the list there. So minus 2, 12, 4, 21, minus 15. Making a mess today. There we go. Okay, and then we find the deviation. So first we have to find the mean. So the mean is, because the deviations involve value minus mean. So mean is the sum divided by 5. 1/5, 21, where is it? Oh, looking in the wrong place. Minus 2 plus 21 plus 4. Still looking in the wrong place. 12 plus 21 minus 15, like that. Double check that because my eyes seem to be crossed. So minus 2 plus 12 is 10, plus 4, 14, plus 21 is 35, minus 15 is 20. So we get 4. It came out nicely. That's not by accident. I made that happen, so life would be easy for us. And then the deviation is value minus mean. Minus 2 minus 4, 12 minus 4, 4 minus 4, 21 minus 4, minus 15 minus 4. Okay. So we get minus 6, 8, 0, 17, minus 19. I'm checking my notes just to be sure I haven't messed things up too badly. And then we square those. 36, 64, 0, 289, that makes sense, and then 361. I don't actually have 19 squared memorized. That would be nice. It's a nice number. And then we sum those up. 10, 20, 0, 2, 5, 11. Help me out. 2, 5, 11, 19, 25, okay. 2, 7, 750. It is 750. And then, so what have we done so far? We're at this stage. We found the deviations, those are these. We squared them, those are those. We add them, that's this. And then we divide by n minus 1. N was 5. So we take 750 divided by 4. That's n minus 1. And then we take the square root to get the standard deviation. So we get S is 13.69, like that. And finally, well, there's something called the sample variance. The variance is what you get before you take the square root. So this business here that's not square rooted, inside the square root sign, that's the variance. Or we take this sample standard deviation and then square it. So if we square that number, we get 187.5. Or we take 750 divided by 4, I'm supposed to get 187.5. Makes sense to me. So this guy here is this guy here, just before you hit the square root on your calculator. That's the variance. S is the notation for standard deviation. There's no special notation for variance. Sometimes people use V, but ordinarily they just write down S squared because that's what it is. Okay, so we've got range and standard deviation covered, and we're moving on to the next slide. Here we go.